Unit 3.3 is proving lines parallel. The way we prove that two lines are parallel is by proving the properties of parallel lines. The properties of parallel lines were if two lines are parallel, then alternate interior angles are equal. Well, conversely, if alternate interior angles are equal, then we can conclude that the lines must be parallel. We can prove they're parallel because alternate interior angles are equal. So if the lines are parallel, we can conclude that alternate interior angles are equal. Conversely, if we know that alternate interior angles are equal, then that proves that the lines are parallel. We know that if two lines are parallel, then corresponding angles are equal. Conversely, if we know that corresponding angles are equal, then we could reach the conclusion that the two lines that form them are parallel. If two lines are parallel, then same side interior angles are supplementary. Conversely, if same side interior angles are supplementary, then we can reach the conclusion that the lines that form them are parallel. If two parallel lines are cut by a transversal, and the transversal is perpendicular to one of the two parallel lines, then it must be perpendicular to the other. So if the transversal is perpendicular to both lines, then we can reach the conclusion that those two lines are parallel. So if alternate interior angles are equal, or if corresponding angles are equal, or if same side interior angles are supplementary, or if a transversal is perpendicular to both lines, then we could say that the two lines in question are parallel and use these things as the reason. Okay? Some other theorems thrown in the mix here. If we had a line and a point not on that line, if we had a line and a point not on that line, exactly one parallel and one perpendicular can be drawn from the line. Given a line and a point not on that line, given a line and a point not on that line, exactly one parallel and one perpendicular can be drawn to the line. These other things are not perpendicular. See, only one. These things are not parallel. Only one. Through a point outside a line, exactly one perpendicular and one parallel can be drawn to the line. The other theorem is that if two lines are parallel to a third line, in other words, if those two lines are both parallel to this same third line, if two lines are both parallel to a third line, this is parallel to this one, and this one is parallel to that one, then we can conclude that those two red lines must be parallel to each other because they're both parallel to the same line. If two lines are parallel to a third line, then those two lines must be parallel to one another. Here's another example in 3D of two lines parallel to the same line. If this red line is parallel to the blue line and the other red line is parallel to the blue line, then we can conclude that the two red lines must be parallel to one another. Okay? So, conclusion. There's 4 ways to prove that two lines are parallel. 4 ways to prove that two lines are parallel. They are if alternate interior angles are equal, if corresponding angles are equal, if same side interior angles are supplementary, or if a transversal is perpendicular to both lines. And then we had theorem 3.9, which says through a point outside a line, exactly one perpendicular and one parallel can be drawn to the line. And then theorem 3.10 says two lines parallel are parallel to one another. If two lines are parallel to a third line, then those two lines are parallel to one another. Okay? So that's lesson 3.3, and in a moment we will go over 3.3 daily work.